Okay, let's go back to the Earth model again. This model is the model that was created after we added the blue marble texture. Now, if we look at this model using solid shading, we can see that the oceans are relatively flat. We have displacement data for the land surface. And we got that from SRTM. We can also get data for the oceans. Now the SRTM data contains artifacts. You see these little dimples. That's just what you get with the SRTM data if you choose to download a section with the ocean in it. So for the ocean, we can use a thing called bathymetry. On Wikipedia, I'll provide a link. There's this here, general bathymetric chart of the oceans. That's called GEBCO. And you just have to type that into Google and you'll find all kinds of things. Well, it's just data that allows you to create contour lines and other things. These are 3D models converted to flat images. If you go to the GEBCO website, you get taken to here. And here's the data that you can download yourself. And it's in a different format than what we've been used to. 11 gigabytes or extracted to 7.5 gigabytes. It's a lot of data. There's a tool. I've already done all that and I've created images that we can just import into Blender. And I've put them here on this website that I'll give you a link to. This is a website that I've created to store all the files that are part of this 3D Earth topography course. Let's look at the SRTM. So the SRTM is a height map and you can see the oceans are all black. That's basically just saying it's just one value and that's 0. If we look at the GEBCO height map, which I've created for you, 5,400 by 2,700, you can see there's now some color in the oceans there. So we can, that's our height map. So we've got the oceans and we've got the Earth. So we can just use this one image completely and import it as a displacement map. The first one I'll show you is the 8-bit JPEG. And then I'll show you the benefits of using the 16-bit TIFF. Okay, so let's go into that. Let's go into the modifiers in displace and in texture here. Let's create a new texture and edit its properties. For image, we'll choose a file. And here, GEBCO Bathy 5400, 2700, 8-bit JPEG. Open image. Okay, so straight away that is already mapped to the blue marble colors. So all the height map is already correct. And it also includes land elevation data. So we got both. So Pacific Ocean, all around Australia. And of course we can increase the quality by adding more to the subdivision. So I'll go 6. Okay. Now, a few moments ago I mentioned 8-bit. 8-bit means that we have to fit all the height information into 256 possible values. So what we get is when we look at something close up, we get this stepping effect as the height increases. That's because we only have 256 possible values that we can use for height information in an image with 8-bit values. So they're stepping here. Another way to look at it, Mount Everest is that high and Mariana Trench, which is the deepest part in the ocean, is that deep. So that's a difference of 19,842 meters. Now, in an 8-bit image, we only have 256 possible numbers that we can use for height information. So that's basically between each number, say from 1 to 2 to 3 to 4, the difference is going to be 77.5 meters. So what we're seeing here, difference of 77.5 meters. Let's have a look at the 16-bit version. 16-bit has a possible 65,535 values that we can use for height. So 19,842 is under 65,535, which means we'll have much smoother gradients. Let's go back to our texture here and edit its properties. and we'll replace that with a 16-bit version. GEBCO Bathy 5400 to 716-bit TIFF. Yep, and already we can see that that's much smoother. There's a lot more information that we can use for the height there, so we can get much smoother gradients. So let's have a good look at that. I mean, this is much more interesting than looking at the flat oceans. We can see the Marianas Trench it's about here, and the highest part of the Earth is over here somewhere, at Everest. I mean, this is very good too. You can see here that 11,000 years ago, when we were in the last ice age, when the sea level was lower, because most of the water was concentrated at the Earth poles at the time, and Australia and Papua New Guinea would have been more shaped like that, and even Tasmania was part of the main landmass. And this is a good way you can understand what the land looked like in the last ice age, simply because the seas were lower. I mean, this is interesting. I'll let you look at that. The next video, we'll work on improving the resolution. Yes, and when the seas were lower, all of this would have been land as well in the last ice age. Anyway,